So what we learned so far, let's write down a short summary here. We start talking about forming confidence interval for population parameter. Population parameter. This is our goal. So when we read a question, we need to identify the parameter that is being asked about. The population parameter is either, in these two sessions that we went over, is either proportion. So we either been asked to find confidence interval for population proportion, which is denoted by P, proportion P, or we are asked to find the confidence interval for population parameter. That parameter is the mean of population, denoted by mu. So when we read a question, when we read an example, when we read an exam question, a quiz question, first step is to identify if it's about proportion or it's about the mean. Well, when it's about proportion, we need to check normality first. Is the normality met? If the normality is met, we're allowed to go to the next step and find the point estimate. The point estimate is sample proportion. Sample proportion. So the sample proportion, we use P hat. If it's given to us, so we don't have anything to calculate. If it's not given to us, we need to calculate the sample proportion by dividing X by N, the number of successes, divided by the size. After finding the point estimate, we're going to move to find the margin of error. Margin of error. E, which is equal to, so for 95% confidence interval, it's 1.96. Otherwise, in general, we denote it by Z sub C, and we call it the critical value times square root of P hat 1 minus P hat divided by N. After finding the margin of error, we're allowed to form the confidence interval. So the confidence interval is equal to P hat minus E, comma, P hat plus E. Can we say that, hey, we are, for example, 95% confident that we are blank percent confident that the population proportion is in between P hat minus E and P hat plus E. So again, if the question is asking about population parameter, and that parameter is proportion of population P, we're going to follow these steps. Well, if the question says, hey, I'm not interested in proportion, I'm looking for confidence interval, an estimate for population mean, first we check normality. If the normality is met, we're allowed to move to the next step. Next step is to find point estimate The point estimate is sample mean. Sample mean denoted by X bar. We either use our calculator to find the sample mean by adding all of the numbers, the sum of data in the collection divided by the sample size to find X bar or point estimate or sample mean in our collection. After finding the point estimate, we move to find the margin of error. The margin of error. So remember that in reality, sigma or population standard deviation is not given to us. So to find the margin of error, we're going to use the sample standard deviation. So margin of error is equal to T sub C, which is our critical value from T distribution, times S divided by square root of N. S is sample standard deviation. After finding the margin of error, we're allowed to move forward to find the confidence interval, which is X bar minus E, comma, X bar plus E. We can find T sub C in our table by finding the degrees of freedom and the percentages that we have. So finally, we can say that we are blank percent confident that now the population mean is in between P hat, X bar minus E and X bar plus E. Okay, let us fix this. X bar minus E and X bar plus E. Very well, let us make it more interesting. You need to know steps for computing a confidence interval for a population mean, well, population mean or mu. First of all, verify that the normality for sample means are met. It means that your sample size is greater than 30, or you already know the population is normal. 2, determine the critical value T sub C that corresponds to the selected confidence level and the degrees of freedom. Remember that for this, we can use our table, and eventually we can use our calculator to make sure our calculations are correct. Next step, we need to compute the margin of error, E, which is equal to T sub C times S. S is the sample standard deviation divided by square root of N. 4, construct the confidence interval. The confidence interval is equal to parenthesis X bar minus the margin of error, comma, X bar plus the margin of error, and we close the parenthesis. This is our upper limit, and this is our upper limit, and this is our lower limit. lower limit on the left and upper limit on the right. And finally, we say that, hey, the interpretation for confidence interval is we are 95% confident that, we are 90% confident that, depending on the level of confidence, we are blank percent confident that the population mean is a number between these two numbers. Okay, give us more interesting example. Well, what do we have here? Constructing confidence intervals. Number 13, suppose that researchers measured the resting pulse rates of adult males who were involved in a study of the effectiveness of bicycle exercise regimen. The table below shows the participants' pulse rates in heartbeats per minute. You should assume that these values are sampled from a normal population. So as you can see, if we go back up, the normality is met. N is greater than 30, or the population is normal. Construct a 90% confidence interval for the mean resting pulse rate for all adult males. Well, okay. I have 90% confidence level, and this is my data. Well, what do we need? We need to follow the steps. The very first thing that we need is that the normality is met. So first thing, normality. It's already saying that, hey, the population is normal. Well, okay. The second step, what is our point estimate? Point estimate. How do I know if it's p hat or if it's x bar? Which one of these the question is asking about? So take a look at this. It says, hey, they measured the resting pulse rates, and the table shows the participant pulse rates per minute, and it is normal. Okay, so far I don't get any information. What about the last line? It says construct a 90% confidence interval for the mean. Okay, I found the word that I'm looking for the mean. So it means that I'm dealing with X bar. I'm not working with the proportion. I'm working with the mean. So I need to calculate X bar, and then I need to find the margin of error, which is TCS divided by square root of N. So in the next step, I need to find S, sample standard deviation, and also need T sub C, the critical value. And in the last step, my confidence interval is equal to X bar minus E and X bar plus E. So let us enter all of these numbers in our calculator and start calculating X bar and S. These two critical information are essential for our calculation. So first of all, I'm going to reset my calculator. Just want to make sure I don't have any left off functions, anything here. So second plus, I need to reset two things. First of all, I need to reset all RAM, and then second plus. I need to reset defaults. Let's go to defaults, reset them all. Well, okay, now our job is to enter all of these numbers here. So we're going to go to stat. We're going to go to stat. And then we're going to go to edit. We're going to enter all of these numbers in L1. Entering L1. Okay, one by one, we're entering these. I have 65, 82, 87, 64, 77, 89, another 77, 73, 78, 88, 79, 83, 85, 89. It was 87, am I right? Do I have any 89 here that I can get rid of eventually? No, it seems like I need to fix this. It is 87. Then 82. Then 91. 87. 85. Another 87. 73. 88. 78. 74. 78. And 88. Well, 82. 77. 59. 97. 84. 87. 85. 87. 83. 79. 73. 83. 85. 87. 91. And finally, 99. Okay, we entered all of these numbers. Well, what's the next step? The next step is go back to stat. Now we need to calculate. Stat, calculate one variable. Enter. Every information is entered in L1, so I'm good. Let us do the calculation. So as you can see, your X bar is 82.02. So X bar is 82.02. Your S is 8.13. And N is equal to 41. Very well. So I found my point estimate, which is 82.02. Now I need to find the margin of error. To find the margin of error, for now, I'm not going to use my calculator. I'm going to just use the calculator to eventually make sure I did everything right. So I'm going to put it away. So now I'm looking for my table. My table says I have 90% confidence level. So confidence CL, confidence level, is 90%. The degrees of freedom, which is n minus 1, is going to be 41 minus 1, or the degrees of freedom is 40. So 90% and degrees of freedom is 40. 90% with degrees of freedom 40, the critical value is 1.68. So T sub C is 1.68. Now I can calculate the margin of error. Margin of error is 1.68 times S divided by square root of N. Okay, let's take a look at this. Let's take a look at that calculation. 1.68. My S is equal to 8.13 divided by square root of 41. .68 times 8.13 divided by square root of 41. So it gives you 2.13. The margin of error is 2.13. Now I'm allowed to move on to my confidence interval, construct my confidence interval. My confidence interval is equal to x bar 82.02 minus the margin of error 2.13 and 82.02 plus 2.13. So confidence interval approximately is around 80 and around 84. So this is the approximation of my confidence interval. So what's the meaning of that? It means that we are 90% confident that the mean of population is in between 80 and 84. We are 90% confident that the population mean is between 80 and 84. Let us use our calculator to make sure we calculated everything correctly. Very well. Okay, so here we go. We go to stat. We go to test. Stat. Then tests. Remember that we need to find T interval. T interval. So click on that. We're using the data that we have. T interval, the data, we entered the data in L1, and then, okay, now see the confidence level is not 95%, it is 90%. So make sure this is correct. Let's do the calculation. Let's see what do we get. Okay, the confidence interval that we have is 89.88, which is around 80, and 84.16. So we got a quite good approximation estimation for our confidence interval. Our calculator shows that everything is correct.